and that's all right. I want to give you the overview of what the first derivative test is. I think who should call him? Donald?
Yo.
What were we trying to find basically all last section and or what you were working on today?
Critical numbers. Or where the critical numbers are located.
Mm-mm.
No?
Critical numbers were used to help find these things.
Oh, extreme.
Okay. So we were finding the absolute max and absolute min. The first derivative test is going to be the method for finding relative extrema. So we're going to be finding relative maxes and mins. So they represent different things, and so you have to find them differently. Absolute is sort of straightforward because you just plug numbers in to find the heights. But relative, you can't do that. Relative extrema aren't going to have, like you could have two hilltops that, you know, they're both relative maxes, but this one's lower, so you're not really going to be able to figure out what it is. So for relative extrema, we have a different method. There's basically like 4 pages of notes kind of leading up to the method, but I've already sort of been like feeding it to you. So at the beginning of absolute extreme, we talked about how, I asked people how you could figure out where the top is, and a handful of people had already figured out you could figure out, words are hard today. You could find when a graph is increasing and decreasing, and that would be a top. That's the method we have to use to find a relative max. You figure out when your graph is decreasing and increasing, that's going to be a relative min. Now the easy part is when it changes between increasing and decreasing. And I bet Spencer could tell us when that happens. When does a graph change between increasing and decreasing? When the derivative is 0 or undefined. Yeah, I noticed. Your expert level dropped slightly. So, I'm going to kind of skip the first couple 3 pages of notes because it's just, well, it's 3 pages to tell us to find increasing and decreasing in critical numbers. But that's what we're pretty used to. Now, there is one portion of these notes that I want to highlight and point out. This is basically the steps, but we're going to do those together. On the AP test, the method for doing the first derivative test is you create this little chart with like plus signs and minus signs that stand for increasing, decreasing, etc. But on the AP test, that chart isn't considered work. And it's very strange to me that they specifically point out that you're not allowed to use this sign chart as your work. Like, you can't use this as an explanation for why there is a relative max here. So, just trying to point this out. If you want to highlight it in your notes or something, go for it. On the AP test, you have to use actual words. You can't say the graph is increasing. Or, I shouldn't say, you can't say the graph is increasing in this section. You have to physically write the derivative is greater than 0. That's how you prove something is increasing. It's, I don't know, it's annoying. Now, I'm not going to focus on that. I'm not going to make you do that on the test. Maybe I should, just so you get used to it, but I probably won't. Let's do this one. And I'm gonna do a full problem with you. I'm gonna sort of ignore these directions, because I think time-wise, I think it'll benefit us. So we are going to find this, but we are also going to find relative extrema. I already forgot, relative. I was looking for it written down somewhere else. Okay, now, finding, increasing, decreasing, relative extrema, they are all absolutely dependent on only one thing. Spencer? Next. Critical numbers. Okay. Spencer, do you want to choose the person that's going to help me do this? From this section. Marvel, I need you to help me find the critical numbers. How do we go about doing that? Well, I don't have that yet, but that is correct.
2x squared
Oh.
minus 2x.
Whoa. So you're giving me the derivative. Okay, so 2x squared
Minus 2x.
minus 2x
Minus 4.
minus 4. Oh dear. Now this goes back to algebra, where you guys dislike. We have to factor that. Now you can factor out a 2 if you want. Oh, this isn't even gonna factor right, is it? Oh yeah, it is. So minus 1x minus 2 would be minus 2 plus 1. Do you remember how to factor if there's a number in the front? Multiply the outside numbers, or do guess and check. Guess and check is actually much faster for people who can do combinations in their head. Even though guess and check is usually frowned upon, it works well for factoring like that. Okay, so we have well, I found 2 answers from this. Marvel, who's gonna help me answer the next part? Sebastian. Great, I forgot to like specify a section. Go ahead.
Wait, I have a question. Don't you have an x equals 0 too, because you set the front to?
If you set the front, it would say 2 equals 0, and then that gives you no solutions. So if it was an x, that's where 0 is an answer.
Okay.
Yeah, sorry, I overlooked that part. Are both of those critical numbers?
Yeah.
Okay, what's our interval for this problem?
There isn't, I believe it says.
It's an open interval.
Fine though.
So that means it doesn't specify, but that is implied it's gonna be negative infinity to infinity. So yes, these are both critical numbers. Okay, excellent. I don't know if you want me to label them or not, but so just to reiterate, a critical number is where something happens in your graph. We don't know if that's where it flattens off or if it's vertical asymptote or something, although we do actually know that, but we're going to pretend we don't. So something happens at those 2 spots. Basically, everywhere else on the graph, it's just going up or going down. At these spots, it either flattens out or goes undefined. So something happens there. So what we're gonna do is draw a number line, which is the beginning of our chart. Now, our number line for this one is negative infinity to infinity because that's what they didn't tell us. And we're going to draw sections. I'm gonna take my critical numbers that I found and put them on my number line. So, numerical order, -1 and 2. Good. Got it? Okay. Now, like I was trying to say, our graph is only going up or down except for at those two spots. So if we want to figure out negative infinity up to -1, we're going to pick a random number from that section and put it in the derivative to figure out if it's increasing or decreasing for that section. So my test number for here, what's an easy number from negative infinity to -1? Pick the easiest one you can think of. Did I give 0? We can't use 0 yet. -2 I would think would work, or -10. Sometimes the 10s are easy to calculate. We don't actually want an answer, we just want to know if the answer is positive or negative. So -2 works just because this derivative is not bad. So -2 would give me 8 plus 4, 12, minus 4. So I have an answer of 8, which is positive. Sebastian, can you call on somebody from that section? Far over there. Does a positive slope mean increasing or decreasing?
Increasing.
Perfect. So, on the number line, what am I doing? FYI, thanks. There's a ton of ways to set up these number lines. It doesn't have to be exactly like I'm doing. I just like to do it so that it's kind of clear to me. A positive slope means increasing. What kind of a slope was at x equals -1? 0, because we set the derivative equal to 0. So we've got positive slopes, we've got a slope of 0. Now we're going to figure out this middle section, what kind of slope it has. And from -1 to 2, obviously 0 is the easiest one to check. So we are going to test it in the derivative. What happened there? 0 gave us -4. -4 is negative. Shocking. Negative means it is decreasing. So up above, I'm going to put some negative signs and write decreasing. Oop. And then at this other critical number, we also know it was a slope of 0 because we set it equal to 0. Now, if it was an undefined slope or a vertical asymptote, I would write that too. Okay, so then we only have one more section left to check. What time did we get done? 6. Yeah, we're good. So let's try, I don't know, let's just do 10. 2 would have been fine. 10, so this would be 100, 200, minus 20, so 180, minus 4, 176. 10 is just a lot of times an easy one to calculate in your head, figuring out positive, negative answers.
For the end ones, wouldn't like doing negative infinity and infinity work less, because then you can just estimate about where it would be.
Sure. I mean, if it's easier for you, go for it. No, I would think that would be, well,
It would be like that theoretical non-math thing and stuff.
I wouldn't do that.
Okay.
It's not like it's wrong, but like it, I don't know. I'm trying to think of an example where it might not work. Should work?
Like me thinking about it.
Yeah, it should work, but I guess I've never done it. No, I don't know. You could certainly try it like off on the side mentally and see if it ever is different. Okay, so positive meant increasing. Now, here is where I usually do it different than most textbooks show. Most textbooks just have you fill out this, and it's not bad, it's not wrong. What kind of a relative extrema is it when we go from increasing to decreasing? It's a max. Now me, when I do that, I have to mentally picture in my head up, down. Like, I don't have it memorized, increasing to decreasing is max. So often what I will do is I will just make like a super rough sketch underneath. Increasing, flat, decreasing, flat, increasing. And I do that because it's just easier for me to visually picture max and min. You don't have to. I just do that because it helps me. If you're good at just reading that info and then coming up with the answer, great. So we have a relative max where? Okay, we have a relative max at x equals 0 or the point 0 what? Where do we plug it in to get that answer? The original function. The original function gives you the height. So, 2. Luckily it's 0.
Wait, how is it x equals 0? I thought it was
Isn't it x equals
negative
1?
Because I read the wrong number.
Oh.
Good. I was like,
I was like, I thought I was starting to get it.
Yeah, that would really screwed you guys up. Yes. Oh, now I gotta plug that in though, huh? So negative 2/3 minus 1, so negative 1 2/3 plus 4. 2 1/3 plus 2, 4 1/3, 13/3. Probably. Probably want to check that on calculator or something. Now, if you plug the number in and don't get an answer, like, you know, if it's undefined, a whole, a vertical asymptote, if you plug your relative extrema in and don't get an answer, it's not a relative extrema. A relative extrema has to be an actual point. Otherwise, they don't call it a relative extrema. And then the second one is relative max because it's at the bottom. That one I actually caught. Trying to write and talk at the same time is way harder than it should be for a teacher. It's a good thing I'm new to teaching. I've had no time to practice this at all. Relative min at x equals 2. Sometimes they'll just ask for the x values. Sometimes they ask for the points. Did anybody figure that one out yet? Okay, so 8 times 2/3 is going to be 16/3. Minus 4, which is going to be 12/3. Minus 8, which is going to be 24/3. Plus 2, which is 6/3.
I think it's negative 14 over 3.
That one?
No, like
No. Oh, the final answer. Gotcha. I was gonna say, I thought that, like, you were making me question my multiplying. So negative 26. Not negative 26. 4. Minus 24 would be negative 20 plus 6, negative 14. Yep. Negative 14/3. So, I didn't even get to write down the interval of increasing, decreasing. Oh well. We will definitely we're gonna do a lot of them tomorrow. The interval is actually much easier than writing the relative extrema. Okay, this is the general process for the first derivative test though. That's what we have to do on every problem. They go slow.